Good morning, students. Today we are discussing about the topic of GCD of two integers, generating prime numbers, compute the nth Fibonacci numbers. So here the introduction of GCD, prime numbers and Fibonacci. This presentation covers the fundamental concepts in a number theory. So here we observe that there is a number theory, numbers algorithms, theorems, theory like we will explore the GCD of two integers, prime number generation and Fibonacci sequence. In last topic we discussing about the Fibonacci sequence. Here we discussing Fibonacci numbers. Understanding these topics to essential for computers and mathematics. Next, what is GCD? The GCD is the greatest common divisor. The full form of GCD is greatest common divisor is the largest positive integer that divides two or more integers without leaving a remainder. It is useful in simplifying functions and solving problems involving ratios. Here we observe that the GCD greatest common divisor is the GCD is also known as the highest common factor. Like this, for example, we observe that lowest form a by b when GCD of AB is 1. That is the greatest common divisor is 1. Example, GCD of 16, 24. So 8 is divisible by both the numbers 16 and 24. So 8 is the greatest common divisor. So here we taking the example, that is which two numbers or three numbers are divisible with one common number is the highest number of positive integer, and that is the greatest common divisor. It is useful in simplifying fractions and solving problems involving ratios. This method includes several factorizations and algorithms. We apply these GCD. Next, Euclidean algorithms for GCD. This Euclidean algorithm is the effective method for computing GCD of two integers. So the most popular algorithm, we used the GCD of two integers. It works by repeatedly applying the principles that GCD A comma B equal to GCD B comma A mod B. So it works repeatedly applying these principles, GCD of common factor or greatest common divisor, whatever it's applying repeatedly to find out the accurate solution. The process continues until one of the number becomes 0 and other number is GCD. So here we applying two numbers. So this process we continues the until in that both number one number must be a 0. So remaining the number with the GCD, that is the greatest common divisor or greatest common factor. Here are the examples. Find GCD of 1, 2, 3 and 36. So we find out the 123 divided by 36 is 3. Remainder 15. So like this we find out the GCD. Next, example of GCD calculations. Consider finding the GCD of 48 and 18 using the Euclidean algorithm. First calculate 48 mod 18 which equals to 12. So here we observe that first we calculate the 48 and 18 which is divisible, it is equal to the 12. Then compute the GCD of 18 and 12. So firstly we calculate the 48 which is divisible, that is a 12. So next we apply the GCD with both 18 and 12 to continue this process until reaching GCD, that is 6, 0, resulting in a GCD of 6 is the greatest common divisor or a greatest common factor. Like this we use in the GCD calculations. Next, introduction to the prime numbers. So next our topic is the prime numbers. So this introduction is here we observe number trick and example. The last digit is a 2, 4, 6, 8 or 0 and even numbers. So 1, 1, 5, 4 is divisible by 2 as the last digit is a 4. So here we observe if we get any number to what is a divisible, that is a prime number or a odd number or factorial, that is number is ending with a positive number, it is divisible by the positive number, that is an even number. So the sum of the digit is multiple of 3, then 15 is a multiple of 3. So we observe that the 357 is divisible by 3. We find out that. So first add those numbers, 3 plus 5 plus 7, it equal to 15. Then 15 is the multiple of 3. So the last digit of 5 or a 0. Then we observe it is divisible by 5. So when observe, we have observed the fifth table, that multiplication always ends with a 5 or 0. So here we observe that our divisible number is, it ends with a 5 or 0, it is divisible by 5. So they play a crucial role in a number theory. So it's very usually apply in a number theory for cryptography and computer algorithms. That is, for example, we apply in a computer algorithms is divisible the numbers, or divisible with 5, divisible with 2, even numbers like this. The first few prime numbers include the 2, 3, 5, 7, 11 and 13. So these are the prime numbers. Next, generating a prime number. So how to generate a prime number? Before we discussing a flow chart, right? So using that flow chart, we generate a random n bit odd number using a prime numbers. There are several algorithms for generating a prime number up to a certain limit. So here are the sum of limit, that is a prime number. So n prime numbers like this. The 7 of heuristic is a popular and efficient method to finding all prime below a given number. So here we observe that generate a prime number is divisible with first few prime numbers. So the list of prime numbers also is divisible with the prime numbers that is not divided by any prime. So perform a Rabin-Miller primary test. So here are the some of the tests to identify the prime numbers. That is, in that one of this the Rabin-Miller. So assume number is a prime. Next, this algorithm iterates marks the multiples of each prime starting from 2, leaving only prime numbers. Next, 7 of heuristic steps. So to use these steps starts with a list of integers from 2 to n. So these are we are discussing about the prime numbers, right? It starts with the 2 to n factors. Like this marks the first prime number 2 and eliminate all of its multiple form and the list. Repeat this process for the next unmarked number. So until multiple times this process is repeated to find out the accurate GCD. That is the greatest common divisor. So next one, applications of a prime numbers. For these prime numbers we use in a cryptography. Prime numbers is 0, 2, 4, 3, only two factors itself. One, it can't be divided further by other number without leaving a number. So before we discussing that if we take a two numbers, in that one number is the answer is 0, the remaining one is the GCD. We find out like this. So that's why here are the processes. The two numbers are in that two numbers only one factor will be divisible by itself. So they are used in algorithm like RSA, secure data transmission, like this. So in that it divides the data into the multiple packets like this. Additionally, primes have a applications in hashing functions and random numbers generation. So here is the hashtag functions we use in that. Next, understanding Fibonacci numbers. So before class we discussing the Fibonacci sequence. It's the understand the Fibonacci number. The Fibonacci sequence is the series of numbers where each number is the sum of two preceding one. So sum of two numbers is the answer. That is the Fibonacci number. The sequence starts with 0 and 1 leading to 1, 2, 3, 5, 8, 13 and so on. So here we observe that 1 starts with the 1. So 3 ones. So 1 plus 1 middle 2. 1 plus 1 2. 2 plus 1 3. 2 plus 1 3. 2 plus 1 3. So like this, the sum of two numbers, the remaining leading to the prime Fibonacci number. That Fibonacci number appears in a various natural phenomena, including the arrangement of living. This arrangement is for best example is tree. A tree, three leaves tree has the best example for the Fibonacci number. So here the recursive formula for Fibonacci. So here also we apply the sum of formulas, that is the Fibonacci number. The Fibonacci sequence can be defined using recursive formula, that is the f of n equal to f of n minus 1 plus f of n minus 2. Here we taking the nth value, we are substituting the value, that is the f of 5, that is the, and if for example n equal to 5, we substitute the n plus 5, f of 5 equal to f of 5 minus 1 plus f of 5 minus 2. The because cos of f of 0 equal to 0 and f of 1 equal to 1. This recursive approach is the straightforward but not insufficient large are due to the repeated calculation. So here we not apply the repeated calculation, just substituting the value that we are taking it. Next, iterative approach to Fibonacci. So here the iterative approach for the iterative Fibonacci sequence is the correctness loops, conditioning, true or false. So sometimes data will observe here, data will like this. Next here runtime and compile time errors also we find out here. An iterative approach can efficiently compute Fibonacci numbers without the recursion. So loop calculate each Fibonacci number sequentially up to f of n. So some starting with 0, we calculate the value sequentially from up to f of n. It reduces the time complexity to 0 of n and avoid the overhead of recursive function calls. So the mistakes of a function calls also it reduces for the clarity of finding Fibonacci number. Using this Fibonacci formula, example of computing Fibonacci. So for example, it computes the 16th Fibonacci, 6th Fibonacci number starts with f of 0 equal to 0, f of 1 equal to 1. Using the iterative approach, calculate f of 2. So we observe that f of 2 equal to 1, f of 3 equal to 2, and the finally is f of 6 equal to 8. That's the prime numbers. In before we discussing, that is the we applying the formula like f of n equal to f of n minus 1 plus f of n minus 2, we applying that numbers to that formula. So here we get the f of 6 equal to 8. Next, Fibonacci in nature. In sequence appears before we discussing like that. In nature we taking the example is best example tree, 3 leaves tree. Fibonacci sequence appears in many natural formation, that is arrangement of sunflower seeds and tree leaves like this. It is also evident of branching patterns. So here also we observe that branching patterns, trees, spiral shells, certain mollusks. These illustrate the beauty of mathematics and understanding the modeling of phenomena. Some of key concepts is we have explored the GCD, prime numbers and Fibonacci numbers in this presentation. Here we observe that the Fibonacci tree method and factorial method, leader method. So GCD, LCM, GSF, GCF. So we apply these. Each of these concepts has unique properties in a mathematics and science. So these topics are crucial for further studies for number theory, algorithm design like this. Questions and discussions are thank you for attending during this presentation. Finally, we are questions are how to calculate the GCD, prime numbers, Fibonacci numbers like this. Thank you.